Welcome back to The Explainer. Okay, today we are diving straight into the strategic clash that is absolutely shaping the AI era. Because right now, behind every chatbot you use, behind every massive data center powering the internet, there's a fierce, multi-trillion-dollar battle being waged. And it's all over the physical hardware that makes artificial intelligence possible. Yep, we're talking about the global semiconductor market.
Here is our roadmap for today. We've got 5 stops. 1. The semiconductor divide. 2. The ironclad AI alliance. 3. Samsung's turnkey paradox. 4. The hidden market rulers. And 5. The next tech paradigm.
Part 1. The semiconductor divide. Understanding the core components of the tech world.
To really get what's going on, we have to lay the groundwork. At its absolute core, this whole industry is split right down the middle into 2 very distinct types of chips. On one side, you've got memory chips, like DRAM and NAND flash, whose sole job is just to hold and store your information. And on the other side, you've got system chips, or logic chips, like CPUs and GPUs. These are the ones doing all the heavy lifting, the actual logical thinking, calculating, and processing.
Think of it kind of like an office setup. System chips, well, they're the human brain, performing complex thoughts, reasoning, and giving out commands. Memory chips are basically the desk, or a filing cabinet, where you store your files so the brain can quickly grab them when needed. They are totally different beasts. Memory chips are mostly standardized commodities, mass-produced in the millions. System chips, though, they are highly customized, super complex designs built for very specific tasks.
Now, you might assume this market split is somewhat even, but the complex, customized brain system chips actually dominate the field. They make up 70% of the entire global market, leaving memory with the remaining 30%. And understanding this imbalance is absolutely vital to making sense of the current AI boom. Because true artificial intelligence, it requires the absolute cutting edge of both sides working together in perfect harmony.
Part 2. The ironclad AI alliance. The tri-party coalition dominating the AI boom. Listen to this philosophy from TSMC's founder, Morris Chang. We don't compete with customers. Just a simple sentence, right? But it explains exactly why tech giants trust them implicitly. TSMC is what's called a pure-play foundry. They don't design chips, they literally only build them. Because of this, fiercely competitive companies like Apple, AMD, and Nvidia can hand over their most secretive, multi-billion-dollar chip designs without the absolute slightest fear of intellectual property theft or worrying that their manufacturer might suddenly turn into a competitor.
So this creates a hyper-specialized triad that basically has the AI hardware space in an absolute iron grip right now. Nvidia acts as the architect, designing those incredible AI GPUs. SK Hynix supplies the crucial high-bandwidth memory, essentially the massive, ultra-fast desk for the AI. And TSMC sits right in the middle, manufacturing Nvidia's logic chips and using advanced packaging to perfectly bind the brain and the desk together. It is a flawless ecosystem built on absolute trust.
And because of this flawless alliance plus the explosive demand from big tech, Nvidia is pulling in a staggering 75% gross margin on their chips. I mean, let that sink in for a second. In the notoriously difficult, penny-pinching world of hardware manufacturing, that number is almost unheard of. They're selling chips literally as fast as TSMC and SK Hynix can physically produce them, capturing an unprecedented level of wealth.
Part 3. Samsung's turnkey paradox. The struggle of the ultimate empire model.
Now, contrasting that highly specialized collaborative alliance, we have the empire approach of Samsung Electronics. While TSMC is purely a gun for hire, Samsung is an integrated device manufacturer, or IDM. They literally do it all. They design system chips, they manufacture memory, they run their own foundry, and they even make the smartphones those very chips go into. It's a pretty impressive turnkey solution all under one roof. But here's the catch. This creates a massive paradox. It actually scares away major clients like Apple or Qualcomm. Why? Because handing over their top secret designs to Samsung feels an awful lot like feeding a direct competitor.
But wait, here is the plot twist. Despite this massive structural disadvantage in advanced AI chips, Samsung's recent quarterly operating profit jumped an eye-watering 755%. How did they pull that off? Well, while everyone else was frantically pivoting their factories to make high-end AI memory, it created a massive supply vacuum for standard, everyday legacy memory and enterprise SSDs. Samsung just leveraged its massive empire scale to step right in and fill that void, proving that, hey, you don't always need to be in the alliance to make an absolute fortune.
Part 4. The hidden market rulers. the super-rulers controlling the fate of tech giants.
Let's pull back the curtain on the highly secretive equipment makers pulling the strings behind the scenes. Because whether you are the Alliance or the Empire, you literally cannot build anything without these guys. They are the super-rulers, the untouchable materials and equipment monopolies holding the ultimate leverage. ASML from the Netherlands is the only company on Earth that makes the EUV machines required to print cutting-edge chips. US-based Lam Research dominates advanced etching, and Japan's Tokyo Electron completely rules in coding. They essentially hold the keys to the digital kingdom.
To really understand their power, just look at the physical bottlenecks of this AI boom. To make high-bandwidth memory, you have to stack DRAM chips vertically, kind of like a microscopic apartment building. But to keep the total height down, these silicon wafers have to be ground to a fragile 50 micrometers. That is literally thinner than a human hair. The problem? If you use a traditional diamond mechanical saw to cut these delicate wafers, the edges just chip and shatter, ruining millions of dollars of product in an instant.
And that is exactly where hidden rulers like South Korea's Technics step in. Their non-contact laser stealth dicing technology is basically science fiction made real. Instead of sawing from the outside, their lasers create micro cracks perfectly on the inside of the wafer, letting it separate flawlessly without any dust or shattering. Equipment monopolies like this are the silent beneficiaries of the AI boom, capturing massive growth simply because the giants literally cannot defy physics without them.
Part 5. The next tech paradigm. Down cycles, big tech gambles, and physical AI. So right now, hyperscalers, think Microsoft, Google, Meta, they are pouring literally hundreds of billions into AI out of pure survival fear. They firmly believe if they don't buy Nvidia chips today, they are obsolete tomorrow. But history warns us of a really vicious cycle. Chip makers are investing tens of billions into new factories, but there is a 2 to 3 year construction lag. By the time these new factories finally open their doors, the market is usually flooded. If big tech slows their spending even slightly at that exact moment, we hit a sudden, severe price crash known as a memory down cycle. Because you can't just turn off a billion-dollar factory. But if the market actually survives this cycle, the next massive wave of investment won't just be in server racks. It's going to be in physical AI, bringing that super smart brain out of the data center and putting it into humanoid robots and autonomous systems. And this requires an entirely new value chain. We're talking 3D vision sensors so robots can actually see their environment, hyper-precise joint actuators so they can move without crushing things, and specialized low-power chips that process AI locally on the edge without needing a constant internet connection. This is the true next frontier, and big tech money is already flowing right into it.
So, here is the crucial question we are left with as we wrap up this explainer. Are these unprecedented, multi-billion-dollar investments the solid foundation of our robotic future, ushering in an incredible era of physical AI? Or are we simply witnessing a massive overinvestment panic that's going to trigger the greatest hardware crash in history? As the Alliance and the Empire continue their multi-trillion-dollar battle, only time will tell. Thanks so much for joining me today, and keep your eyes on the physical hardware, because honestly, that is where the real future is being built.